Today we're going to take a look at the second half of section 5.4, which is about finding antiderivatives involving exponential functions. So we're going to look at a lot of integrals today. All right, so let's talk about our definition first. So we have u is some function, and it's going to be a differentiable function of x, just meaning that u is a function that you can find the derivative with respect to x. It's the same type of u we've been using for all these other functions we've been dealing with, okay? So we have our basic rule in terms of x, and then our basic rule in terms of u. All right, the antiderivative of e to the x dx is e to the x plus c. And that's because of what we did last class, where we were finding derivatives as exponentials. The derivative of an exponential is itself. Okay, so that means the antiderivative is also itself. There's just a plus c involved because we're doing the general antiderivative. Okay. Now, many of the problems we're going to do are going to have u substitution involved. So if you get it to the point where you have e to the u du, that'll become e to the u plus c, and then you'll replace the u with whatever the u function was, okay? And that's what's going to happen on this first example, all right? So we want to find the antiderivative of e to the 6x plus 4 dx. Now that's not just plain old e to the x, it's e to a function of x. So this right here is going to be our u. So we're going to do u is equal to 6x plus 4, okay? So now we need to know, well, what's du? And the derivative of 6x is 6, and then the derivative of 4 is 0, so this is just 6 dx. Now there's no 6 for a coefficient anywhere, so we're going to divide that 6 to the other side, and we're going to make this 1/6 of du is equal to dx. So that means that this dx right here is going to be replaced by the 1/6 du, and this will become e to the u, okay? So rewriting this integral, we're going to have a 1/6 and a du to replace the dx, and this will become e to the u. Okay. So I put the coefficient out in front, but you can put the coefficient right here if you prefer. All right, so the coefficient can either go out in front or stay inside. But one way or another, we have now taken this initial integral and we've converted it into this format. So that means that the antiderivative of this is just itself plus c. So what we really have here is 1/6 e to the u plus c. That's the antiderivative. To get to our final answer, though, we can't leave u in the final answer because we didn't have u in the original problem. So the very final answer here will be the 1/6 e to the u, which was 6x plus 4 plus c. All right, and there's our final answer. So that's our first example. And I want to remind you that every antiderivative problem, you can check your answers by finding the derivative of what you came up with. If we were to find the derivative of this, it would be 1/6 this exponential times the derivative of this exponent, which would be 6, and the 6 and 1/6 would cancel off to give us just e to the 6x plus 4. The derivative of plus c would be 0, okay? We're going to go through 4 additional examples. We're just going to do them in separate videos. So this is your introduction to finding antiderivatives with exponentials.